Alright, so step 3, horizontal and vertical components. These are the horizontal and vertical components of our initial velocity. So what you should have done is you should have picked an angle. So you're wanting to fire your rocket. I'm going to do 45 degrees because I imagine most of you will pick this angle of 45 degrees. Now, our initial velocity going back was 9.8. So I'm just going to write 9.8 on here. And so basically, the rocket was facing straight up, and we've decided to face it on a 45 degree angle and shoot it at, and we assume, and we're assuming here, that it's going to remain at 9.8 meters per second. We're assuming that whatever the speed was going straight up initially, it would remain the same at the angle. Because if your rocket stays the same and the launch pad was all set up the same, it should technically go the same speed at the beginning. All right. Now, when you are working on angles, you actually have to find a vertical and horizontal component of this. Okay. And what I need to do is I need to make this a lot bigger, actually, to make your life easier. This line is 9.8, and our horizontal component travels this way, and our vertical component travels directly up, right? And you make it so the horizontal component ends where our diagonal does, and the same with the vertical component. Our angle being 45 degrees. Now, what you want to do is you want to sort of make this into a right-angled triangle, and you're just going to use trig to calculate each side. So let's call the horizontal component x and the vertical component y. Right? So I can see that x, we're going to use cos 45 equals adjacent over hypotenuse, so x over 9.8, and then 9.8 times cos 45 equals x. Right? So I'm just going to grab my calculator. 9.8 times cos 45, making sure my calculator is put in degrees mode, and I get about 6.9, right? And I've done that. I'll write meters per second to the -1, and I'm going to write 1 dp. And it's okay to do rounding in this assignment. Just make sure you explain how you did it. Whether it was 1 decimal place or 2, that's fine. Alright. Now we've got to find y, and the good thing about y is the same as this line here. They're the same length. Alright. And basically y you're using sine, so sine 45 equals opposite or equals y over 9.8, the hypotenuse, which means that 9.8 times sine 45 equals y. And I'm pretty sure you just get the same answer. 9.8 times sine 45 equals 6.9 meters per second to 1 decimal place. So I'm going to quickly sort of describe what this means. Basically, it's sort of saying that if your rocket's traveling in this direction at 9.8 meters per second, it's traveling horizontally at 6.9 meters per second, and it's traveling vertically at 6.9 meters per second, which comes in handy when you do the rest of your calculations.